So welcome to this video lesson. Here we will be doing more problems on permutations, which may be a little difficult but easy to understand. So we start with the first problem. How many among the first 100,000 positive integers contain exactly 1, 3, 1, 4 and 1, 5 in their decimal representations? Now 100,000 does not contain 3, 4 or 5 and 100,000 has 6 digits. So we look at 5-digit numbers. Now the digit 3 can be in any one of the 5 places. Similarly, the digit 4 can be in any one of the 5 places and the digit 5 can also be in any one of the 5 places. Since the digits can be repeated, the other 2 digits can be filled in 7 ways each. So total number of ways is 5 into 4 into 3, that is 3, 4 and 5, and then 7 into 7, which is 2940. Find the total number of digits, positive integers that can be formed. This is the next problem that can be formed from the digits 1, 2, 3 and 4 if no digit is repeated. So now if no digit is repeated, number of 1-digit numbers is just 4 and number of 2-digit numbers will be 4 because there are 4 and the second digit can be filled in 3 ways, which is 12. And if there are 3 digits, the number of 3-digit numbers will be 4 into 3 into 2 because the first digit can be filled in 4 ways, second in 3 ways, third in 2 ways, that is 24. And the number of 4-digit numbers will be 4 into 3 into 2 again because the first digit in 4 ways, second digit in 3 ways, third digit in 2 ways and the last digit in 1 way. So the total number of digits, because you can have either 1 digit or 2 digit or 3 digits or 4 digits. So it is 4 plus 12 plus 24 plus 24, which is 64. Next is find the number of proper divisors of 441,000. If you factorize 441,000, you get 2 cubed into 3 squared into 5 cubed into 7 squared. This is the prime factorization. Now if D is any divisor of 441,000, then you can write D as 2 raised to A into 3 raised to B into 5 raised to C into 7 raised to D, where A lies between 0 and 3, B lies between 0 and 2, C lies between 0 and 3, and D lies between 0 and 2. So divisors of D will be 4 into 4, 3 into 4 into 3, because you can have 3 here, can have 4 here, 3 here, 4 here and 3 here. So 4 into 3 into 4 into 3, which is 144. Now we need to find the number of proper divisors. 1 and D are not proper divisors. So number of proper divisors is 144 minus 2, which is 142. How many positive integers n can be formed using the digits 3, 4, 4, 5, 5, 6, 7 if we want n to exceed 50 million, 5 million? Now 3 occurs once, 4 occurs twice, 5 occurs twice, 6 and 7 occurs once. So if the first digit is 5, then the remaining digits, there are 6 digits. They can be arranged in 6 factorial by 2 factorial ways because 4 is repeated twice, which is 360. Now if we have the first digit as 6, then we have 3 is repeated once, 5 is repeated twice, 4 is repeated twice and 7 is repeated once. So the remaining digits can be arranged in 6 factorial by 2 factorial into 2 factorial, that is 180 ways. Because we have a property that if a digit occurs 2 times or 3 times, we divide it by that number. And this can be seen in one of my earlier classes in this course on permutations. If the first digit is 7, then we have 3 ones, 4 twos, 4 occurs 2 times, 5 occurs 2 times and 6 occurs once. So the remaining digits can be arranged in 6 factorial by 2 factorial into 2 factorial, that is 180 ways. So total number of ways will be, taking all the cases together, 360 plus 180 plus 180, which is 720. Now find n if 2 pn2 plus 50 is p2n2. That is nothing but 2 times what is pn2 np2 plus 50 equal to 2np2. np2 is n into n minus 1, so we have 2n into n minus 1 plus 50. 2np2 is 2n into 2n minus 1. So we get 2n squared minus 2n plus 50 is 4n squared minus 2n. Simplifying, you get n is 5. So that brings us to the end of this video lesson. We have practiced a few problems in permutations, and as I always say, the only way to learning mathematics is to do mathematics. So thank you and stay tuned.